All right, guys, welcome back. Today we're going to solve the longest substring without repeating characters. This is a LeetCode medium, and this is a very cool program because it touches a lot of the fundamentals of computer science. And let's go ahead and read it. Given a string, find the length of the longest substring without repeating characters. So whenever we hear, there's two key words here. There is longest substring and repeating characters, without repeating characters. So the very first thing that I hear here is without repeating characters. That means we have to do some sort of lookup to check that there isn't any repeating characters. And the first thing that I think about whenever I think about lookups is, you guessed it, maps, right? So we need some sort of map. Maps are very important. Again, I've said this in my previous video. Very important just because it gives us constant time lookup, and whenever we can leverage constant time lookup, it's definitely going to help us with the running time of our algorithm. So yes, constant time lookup. The next thing I see is substring, right? Subsequence or something. We have to find a smaller subsequence inside of an array or string. So one thing that I think about when I hear a substring is I think about two pointers, having some sort of two pointers. And to feed on top of that is when I think of two pointers and I think about some trying to find the max or the min of a substring or subsequence, I think about the sliding window technique. And that's what we're going to use to solve this problem here. And I'll explain to you guys a very brief explanation of how I'm going to leverage the sliding window in this problem. So let's get started, right? Like I said, we're going to have two pointers. We're going to have a pointer on the very first one, we'll call it the L or left pointer, and then the right-hand pointer, right? So let's leverage that map. So we're going to start off with setting the left-hand pointer. The left-hand pointer, and we're going to look and see what we have here, right? So left and right-hand pointer are going to point at A, and we're going to check, okay, is this subset or this window, so we'll put little brackets around it so it kind of looks like a window. And with the sliding window, there's two cases, right? And the very first, we could slide the window either to the right, we could slide the right-hand side of the window, or we could slide the left-hand side of the window. And it all depends, and if we hit its criteria, right? So whenever you want to move the right-hand side of the window, so let me write it down, move right-hand side of window if there are no repeating characters, no repeating chars. Else, move left side of window. So there you go, guys. Let's follow these two steps to move our right or left hand side of the window, and we'll see that we'll be able to get our longest substring that way. So we know that we've seen A, and A is in the index 0. So in our map, we're saving the key to be the character and then the value to be the index. Very important. You guys will see why in a second. So then we go, okay, considering what we have in the map, do we have any repeating characters? Nope. So like we said before, we're going to move the right-hand side of the window if there are no repeating characters. And in this scenario, we only have A inside there, so there's no repeating characters. So let's move our right-hand side of the window. Move that. And now, here we go. So then we ask ourselves again, is there any repeating characters in this window? Nope. So then we move our right-hand side again. Then we ask ourselves the same question. Is there any repeating characters in this window? Well, yes, there is. So then we move the left side of the window. But we don't just move it by 1 or by 2 or by 3. There's this strategy to how we move the left-hand side of the window. And the whole point of this strategy is to make sure that our new subset does not have any repeating characters. And the way we can make sure that we don't have that is, one thing I forgot to add is anytime we see R, anytime we're at R, we have to push that character in the map of things we've seen before. So let me just update that real quick. So we just added this one, and now we're here. So we check. We use this to check in our map if we've seen it before. So we go, is B in our map? Well, yes, it is. It's right here. So then we use that information to move the left-hand side of the window. So we're going to avoid to have any repeats in our new subset or window. We do this. We move L to the first occurrence of the repeating character, which is B plus 1. So we move L to the first occurrence of B, which is in index 1, which here we are, plus 1. So then that'll lead us for R and L to meet in the same spot. So here's our new window. And then we update B to the new spot, right, which is 2. And we continue. And you guys got to remember here, whenever you see the code, don't get confused. We're not deleting or do anything to the map. We're just updating what the B is, because anytime you can only have unique characters or keys in a map, so it'll just override B to be the new one. So then we check again, is there any repeating characters in this window? And there isn't, so we move the right-hand side and we repeat the process. Is A in the subset, right? It is in the subset, but we got to remember here's another edge case. A is in the subset, but we don't really care about anything to the left of the left pointer, because we've seen it already, we've calculated already. So we could just do a quick check where only worry about characters that are repeating, check if it's repeating, and check that that L is less than. Only apply this logic if L is, only move the L if it matches it. So A, and then the index is greater than or equal to L, which in this case 0 is not less. 0 is definitely not greater than 2. So then let's not even worry about moving L. And there you go, guys. We have the set. We have the length of 2. As you guys recall too, we also had a distinct window here where we had no repeating characters. So here and here would work, and the max of those two is 2, and that is the answer, right? So as long as we remember that we're only moving the right-hand side of the window if there are no repeating characters, and we're only moving the left-hand side of the window if there are repeating characters and the index of that repeating character is greater than or equal to where left is at, because we don't care about anything to the left of the left-hand pointer. Perfect. So now that we know that, let's get started with the code. So we're gonna declare a max. So this max is basically what is gonna be updated every time we see a substring that's bigger than the ones we've seen before. And then we're gonna do our map. This is what's gonna give us the constant time lookup. Then we're gonna implement the logic for our pointers, or our sliding window, which requires 2 pointers. We have the left-hand pointer, and then we have the right-hand pointer. And then there's a simple case where I want to take care of before we enter the while loop, and that would be in the scenario where s.length, where the length of the string is equal to 1. Because if it's equal to 1, then we could just return 1, since we know that there's no repeating characters where a string has a length of 1. Another thing I want to take care of before anything is, because we're starting the left-hand pointer at 0 and the right-hand pointer at 1, I want to make sure that when we enter this while loop, we're going to check if whatever is in the right-hand pointer exists in the map already. And in order to do that, I want to set the very first pointer. I want to set the left pointer already into our map as we've seen it before. Since in our while loop, we're going to start off with the second character in our substring. And to do that, we could do s left pointer and then the index. So let's do that here. As we go, let's go through this scenario here. So map is a 0. and then we have our left here and our right here. Perfect. So then we get started with our while loop, and we're going to stop this while loop anytime the right pointer is less than the s dot length. We're going to keep going while the right pointer is less than the length, and then anytime it becomes the same, we'll exit out of this while loop. So right now here's our left hand pointer at A and our right hand pointer at B. The very first thing we want to do is make sure that B, or our right hand pointer, is not A, is that our current window, it doesn't have any repeating characters. And we check that by checking if R exists in our subset or our window. And to do that, we go if map dot has s right pointer. And remember how we talked about we don't care about anything to the left. If there's a match, we don't care if it's occurred anything to the left of the left hand pointer, right? So we do another check. We go n map dot get, which is the value of the matching pointer, has to be less than, is greater than, has to be greater than or equal to the left pointer. So because we only care about things that are because we don't care about the things that are to the left of the pointer, we give it this check right here. And if both of these things are true, right, like let's say we do have a duplicate, and at the same time, whatever the index is either right at the left-hand pointer or it's greater than, because we're only moving the left-hand pointer up or it's staying put. So that's the reasoning behind this. We will never move the left-hand pointer behind to the left, or we're always moving it right. And this case right here makes sure that always happens. We're only moving the left-hand pointer or the left-hand pointer to the right. Never backwards, never to the left. So if both of these cases are true, then it means that we don't have a repeating character, and we need to update our left-hand pointer. To do that, we do left-hand pointer, and remember we're doing it to the very first occurrence. We're doing it to the very first occurrence of the repeating character plus 1. So in this scenario, we've seen B0 before, B1, and then we move our right-hand pointer to B. So now we check, is B in the map? Yes, it is. Here's B, and then we check if it's in the map and the index is greater than or equal to pointer. Well, B1 is definitely greater to what our left pointing is to, which is 0, so that's okay. So then we update the left-hand pointer, and we look for the first occurrence plus 1. So the first occurrence of B is here, plus 1. So there we updated our L and our right, and we update our window. So that's what we're looking at now. Perfect. So then we check, we move our right hand pointer. So now we're at R, right? But in order to do that, in order to always have these things populated, no matter what, we have to set what we've seen before into the map, which in this case would be the right pointer and its index. And then we do care about the window length or the substring length. So in order to do that, we're going to leverage our pointers, and it's a simple calculation, which is right pointer, because right pointer is bigger, minus left pointer, and because it's 0 index, we're going to do plus 1, and this will give us the length of our substring so far. And then to find out what the max is out of all of them, we could do a simple trick called math.max, and we put in the max compared to the old values with the window length. If window length is ever bigger than the max, then max gets updated. And then most importantly, so we avoid having an infinite while loop, we want to increase the right hand pointer. plus equals 1. There you go. So no matter what happens, we're always no matter what happens, as we iterate through everything, we first check if our sliding window meets our criteria, and if it does, we move the right hand pointer, and if it doesn't, we move the left hand pointer first. Perfect. So then once we hit the right hand pointer, we know that our max is 2, and that would give us our longest substring. But in order for this function to return it, we return the max. And that's it, guys. This should be the solution. Fingers crossed, and let's see. What am I missing here? Not a number. S.length. Oh, we forgot to do the left-hand pointer. So map.get, and then it's very simple. Remember how we said whatever the matching of the right-hand pointer or the first occurrence, plus 1. And there you go, guys. We have a very, very fast runtime, 72 milliseconds, which is faster than 98.41% of JavaScript online submissions. And there you have it. There's the length of the longest substring. If you have any questions, please leave questions in the comments below. And that's it for today. Thanks, guys. Bye.